I'm going to walk you through a set of structural steel specifications. You can see right up at the top here that structural steel is in Division 5, so 5120 is the typical number. And we're looking at structural steel here. Specifications are usually divided into three parts using as a standard. So part 1 covers general conditions specifically for this scope of work. Part 2 is going to give us the products, so the specific information about what is included. And then part 3 is execution. This gives information on how the work should be done. So let's jump back up to the general and step through this section by section. So at the top here we have a summary of the work included here. And what's interesting to see is here is the word furnish and install. So this means that in this scope of work it includes producing the steel, fabricating the steel. So the furnishing would be fabricating, and then installing in steel we're looking at erecting steel. So we've got fabrication and erection of steel, and then there's a lot of other work that needs to be coordinated with the steel. So you can see down here under related work, and many of these items are also in Division 5. So you see these here. Typical ones that you'll see on most jobs are going to be things like miscellaneous metal, steel. Most steel jobs have metal decking. They do not all have structural steel joists or cold form framing. And typically that's not structural. So if we go down a little bit further, we talk about the related documents in this particular spec section, and then we have reference. And the interesting thing to note here is this is where we're going to find modifications to the Code of Standard Practice. So the Code of Standard Practice is the industry standard for production and fabrication, erecting steel. And so in this particular job, there's a bunch of things where that language is modified. Next, we're going to get down to submittals. So in general conditions, or 1330 in this particular project, we'll talk about the specifics of submitting, the procedures for submitting. In the spec section itself, it's going to talk about exactly what needs to be submitted. So for structural steel, we're looking at shop drawings, and that's the detailed shop and erection drawings that we're going to have. And this indicates exactly what needs to be shown on those drawings. And then there's different reports. So if we look at this a little closer, what we're going to see is that typically for structural steel, we're looking at some design calculations for connections, mill tests, that's basically the information from the raw steel, and then bolt certification to show that they're in compliance. Next section we're looking at here is quality assurance, and this talks about things that may be performance specified, such as connections typically in steel are performance specified, which means the contractor is responsible for designing the connections. We also have things that are done in the field and in the shop, such as welder certification here, the design engineer, and then there's other special requirements. Next, you'll see what the process is for looking at changes on the drawings. If the typically in steel, different fab shops are set up to do things in different ways, and so here's the way that the steel fabricator or steel subcontractor can ask for substitutions in sizes to make it work a little bit easier. So as we continue down through the specification here, really important that there's a pre-installation conference so everyone understands what is required by the subcontractor. We get down to field measurements, verified dimensions of members requiring close erection tolerances or critical. In conjunction with this, a lot of times when you have existing field conditions, they need to be verified as well. What we see down here in delivery, storage, and handling is kind of boilerplate, but basically requires that the steel subcontractor coordinates their work with the work of other trades, and that they sequence the work in a way that makes it expedite erection and minimize field handling. And they're going to do that anyways because that's what's going to save them the most money. So those are general conditions specifically for this scope of work, and this needs to be worked with the whole Division 1 section as well. When we get into products, you're going to see here that this is there is a definition in the AISC Code of Standard Practice of what structural steel is, and here we're very specific. So when we're talking about carbon steel, this is where we give the grades, and again, these are industry standards. So typically W shapes are ASTM A992. The rest are usually going to be A36. Tubing comes in this grade here, etc., etc. So you can see how this is where, if there was some specialized steel, it would be designated right here. If there's high strength steel, and this would be specifically indicated on the drawing somewhere. So this basically goes through what is covered, what exactly is covered in the spec section. You see when they're welding, the type of electrodes to use, and then when we're looking at fasteners, we're looking at the specification for those bolts. It's very important to work the specifications with the general structural notes, because the general structural notes will tell exactly where you're required to use high-strength bolts, where you may use standard bolts, and where anchor bolts are. And so it's very important to make sure that you look at the different. The AISC Code of Standard Practice actually indicates that the drawings take precedence over the specifications, which is different than most other trades. So unless it's specifically noted that that is not the case here, that the drawings do take precedence if you run into a discrepancy. So here we're looking at the different things. Rebar is listed here, but typically if we're talking about rebar that's not shown with the concrete, rebar that is part of embedded in concrete reinforcing is usually found in Division 3. This particular job is a pool, so it talks about something very specific about stainless steel in the pool. Shear stud connectors are called out, and then this is something a lot of people may miss is primer here. Now you go to Division 9 for paint, but this basically shows how that the steel needs to show up with primer to the job site before it gets its final coat. So moving down here, we can see that there are some miscellaneous things not shown here, and so this is kind of the designer covering themselves. Provide anything else you need to do in order to complete the work. So that covers a lot of little bases. So that's the actual products. Next we get into fabrication. So fabrication is going to tell us exactly how to put things together. And again, where it's silent in the specifications, the AISC Code of Standard Practice comes into play. So if we're looking at fabrication here, it talks about tolerances. In this particular case, it talks about how to treat steel that's specific when it's in public view, workmanship, and things like that. Down here, it talks about how the contractor is supposed to do the welding, do the bolting, do the shop cleaning, and most of this again is going to be standard practice, but it's really important that you read through this to make sure you don't find something that isn't much more detailed or requires more detail than you'd get in standard practice, because that could end up affecting cost and schedule. And finally down here we're talking about shop painting. So up above we talked about the product to use for the shop priming. So here we're talking about priming, and this tells how thick to put it on, and you'll note if we go back up it tells us in the primer section exactly what to use. So depending on the application, these are the different actual primers that can be used. And you'll notice many of these have approved substitute, and so there's a whole process in Division 1 that talked about how to get an approval of a substitute element. Part 3 talks about execution. So there's a lot of language here that requires the contractors to verify conditions, and so we're looking at it's incumbent on the subcontractor to get out and make sure that things are as they expect, examining the areas and conditions under which the work will be done. And here we have things talking about the preparation of the site. So here it's required by the the steel to retain a surveyor to get the benchmarks, elevation of concrete, etc., and then deliver anchor bolts, base plates, so things that are going to be embedded or built into the structure. And then finally, this is the getting this set up to to get ready to accept the steel. So this may, depending on the general contractor, this may or may not be excluded from their work. However, a lot of times the structural steel erector wants to do these so that they have control over them, and it helps speed up the work they're doing. Once we're getting into building the structural steel frame, we get into the erecting of the steel frame. Again, we're looking at just keeping to erection tolerances, and here it says specifically comply with the Code of Standard Practice, and here we have except as follows. So here's where we would override the Code of Standard Practice. So the Code of Standard Practice allows for usually much more deviation, for instance, of columns in vertical and where the locations of the center of the columns are. And so this is where the tolerances are much tighter. And you'll see a few more details through here. And if these tolerances are really tight, it's going to, again, affect the cost of the project. Down here is talking about what happens if you need to do field modifications. And so this would be the RFI process to go through there. And here we're talking about different things like when they can actually start putting the beams and girders and the concrete. We're looking at the design strength, say, of concrete, or if they're reviewed by the architect or structural engineer of record. We're looking at temporary bracing. It's the responsibility of the steel erector to provide any temporary bracing, and they must be removed when they're no longer needed. And then finally, it talks about how to do the field connection. So here is where you would have anything specific, talking about where, in this case, where things are exposed to public view, and etc. Quality control is another very important thing that you need to look at for structural steel. So again, there's a survey that's done to make sure that everything's put in place, and they have to be submitted. That's part of the submittal process. There's testing that has to go on, especially for welding and bolting in the field. And then if there's any need for coordinating and getting assistance here, the testing agency needs to get a full set of the shop drawings, erection drawings, etc. As we go through this, we see a few more places where we have the specifics of what needs to be inspected. So we've got the overall steel inspection, the welding inspection, the bolt inspection, the shear stud inspections. And again, this gives the very specificness of that. Finally, there's always a chance that the priming or galvanizing is going to be damaged slightly during erection, and this provides how to clean it up and repair it at the end. So this is a very brief overview of how to navigate a set of structural steel specifications.